Hello, Ron.
Hello.
We haven't actually met before, so this is maybe a bit of a violent intrusion in your private life on my behalf. But, well, we're here at the JISBD in San Sebastian, and you had a keynote, which I found personally very interesting. Could you just very quickly, I know it was nearly an hour, but we've got about 5 minutes of YouTube space. Could you tell us something about it?
Oh, the keynote?
Yeah.
Okay. When people are creating programs, models or whatever, they usually become very complicated. And the issue is that if you want to understand them, you have to realize that these large complex models come from simpler models.
Mm-hmm.
And from simpler models, they come from even simpler models, and you keep going backwards in time until you come to something that's understandable. When people develop programs, they're actually incrementally developing these programs in their minds, and what you're seeing is the result. If you can show how the programs have been developed and actually prove properties about those programs as you go along, you will have a much better way of understanding how the program was constructed, how it's easier to change, and how it's easier to explain and also test. And it's a methodology by which you can understand, solve for complexity, and you can eliminate it.
You developed a couple of examples during the keynote, one referring to redundant servers, well, failover systems,
Mm-hmm.
and so on. The other to parallelization of databases.
Mm-hmm.
I would say that with recent hardware advances, where we've actually got parallel architectures even when we haven't asked for them, there's a tremendous amount of software that has to be redesigned because they weren't really thought to work on that type of architectures to start with. Do you think your type of analysis can actually help, let's say, this reuse of software, or redesign of software that has to take part? Because we're not going to go in. Yeah.
A lot of this stuff is incremental development. It deals with refinement. I was reading that basically refinement is quite good for the second time around, so that you can explain what you've done previously. Often you're not really sure what you're building the first time.
Yeah.
And if you've heard the phrase, we've done this so often we've got it down to a science, well, that's very much the case here. After you do things a number of times, you begin really to understand what are the fundamental ideas that you're dealing with, and that you can develop these systems better the second time around. Can it be done the first time? I think so, but you have to be familiar with the techniques, and that takes some effort. Not much, but it takes some effort. You have to have some experience.
Yeah. How long have you been working on this line of search?
How old am I?
No, how long have you been working on them? Have you always been thinking along these lines?
I've been always thinking along these lines.
I see.
That makes a difference. I can't think in any other way.
Okay, I'm going to hang this on YouTube, as I said before, so do you want to make use of the space to say hello to anyone or something like that?
No.
No? Okay. Oh,
Thank you.
Well, thank you so much.
Bye-bye.
Bye.